In Chapter 13, we'll take a look at the floating point unit. In the lab, we'll use the FPU to calculate values for a sine function. Floating point is a way to represent real numbers on computers. There are several IEEE floating point formats: half precision at 16 bits, single precision at 32 bits, double precision at 64 bits, and quadruple at 128 bits. IEEE 754 is single precision and the format used on the Tiva C-series devices. IEEE 754 defines a single precision floating point representation. In the top figure, note the sign bit on the far left, followed by 8 bits of exponent, and finally 23 bits of fraction. In the other two figures, you can see how the numeric representation in memory can be converted into a decimal number. The floating point unit on the Tiva C-series devices provides floating point computation functionality that is fully compliant with the IEEE 754 standard. The floating point unit supports single precision adds, subtractions, multiplies, divides, single cycle multiply and accumulate, or MAC, and square roots. The figure at the bottom shows the additional instructions added to the base Cortex M4 set by the floating point unit. There are three different modes of operation for the floating point unit: full compliance, flush to zero, and default non. Full compliance mode is where the floating point unit processes all operations according to the IEEE 754 standard in hardware. There is no additional support code required. In flush to zero mode, a very small result, as described in the IEEE standard, is replaced with a zero. In most cases, that's probably what you want to do. Non stands for not a number. In default non mode, the result of any arithmetic data processing operation that involves an input that's not a number or that generates a result that's not a number will return the default non. If you perform a divide by zero, that's a non or not a number. The floating point unit has 16 64-bit double-wide registers D0 through D15 and 32 32-bit single-word registers S0 through S31. The FPU is disabled from reset. You must enable it with a TivaWare API function call before you can use any floating point instructions. The processor must be in a privileged mode to read and write from the control register, and the API performs its function. The floating point unit sets the accumulative exception status flag in the exception register as required for each instruction. The floating point unit does not support any user type traps that you might write. The processor can reduce the exception latency by using a technique called lazy stacking, which is supported by a TivaWare API. Lazy stacking means that the processor reserves space on the stack for the state, but doesn't save that state information to the stack unless it's necessary. In Lab 13, you'll experiment with using floating point code to generate a sine wave. You'll profile the code to determine how many CPU cycles it requires to execute.